Okay, everybody, this is the beginning of Chapter 3. This is Chapter 3, Section 1, and we're going to be looking at some pretty important things here. So it's really important that you go back and reread your notes, highlight things when you reread your notes. So you really need to make sure you put some time into this stuff, okay? So we're going to start off with these 4 definitions here at the top. So if you want to go ahead and put those headings in. And then I'm just going to pull out the definitions all at once. So if you want to hit pause once I do that, hit pause and then write them all down. Then you can come back and hit play. Okay, so let me drag these out and let you guys write these notes down. And then I'll probably draw some pictures of them or do some illustrating of what some of them kind of mean. Okay, so there you go. Okay, parallel lines are just lines that are on the same plane. So if you think of your screen as a plane, you can have lines all over the place, but you could have lines that will be parallel, and parallel lines just don't intersect, so they look like that. There is a symbol, though. I want you to write this down. There's a symbol that looks like this. So it's just 2 lines that are parallel to each other, but in this case, they're drawn vertically. That's the symbol for parallel lines. So you'll see that in some of your work that you have to do, or a test or a quiz. Just that's the symbol for parallel lines. Okay. Skew lines are a little bit different, and these are lines that are not in the same plane, but they don't intersect. Okay, so I'm going to give you kind of an illustration. You know, if you're in a room somewhere, or just you're thinking of your bedroom or the kitchen or something like that, you know, you got walls and ceilings and the floor. Well, the walls and ceilings or floors, they're considered planes. They're a flat surface, okay? And they intersect. And one thing you gotta remember from before, another chapter, that where planes intersect, they intersect at a line. Okay, so like a floor and a wall, they intersect at the bottom, and they intersect in a line all the way along that wall and floor is the intersection of 2 planes. Okay, so let's think of that. You got a wall and you got a floor, they intersect. And if you look across the room at the other wall, well, there's probably, if your room is pretty rectangular or square, there's 2 walls that meet. And then where they meet is a line. And so skew means that they're not going to necessarily be parallel, but they're not going to exist. So where 2 walls meet, when they meet, they form a line, and that line is vertical. Okay, so hopefully you can see that somewhere wherever you're at. But you have a wall and a floor on the opposite side of the room. Okay, it's kind of hard to illustrate with us not being together, but where the wall and the floor meet on the other side of the room, that line's horizontal. Okay, now those 2 lines that describe where the planes intersect, they're not technically parallel, but they're never going to intersect. So we come up with another term called skew. Okay, so that's a kind of a big one. You may want to put, you know, a star next to that and come back to that, because that'll show up again. Okay, parallel planes are just like it sounds, parallel planes. So if you're back in that room again, let's take the floor and the ceiling. Both of them are planes, but they're parallel. They're never going to intersect. Okay. All right, a transversal. Now this is a big one, and we're actually, the next section we kind of get in depth a little bit more with the transversal. But it's a line, so if you can go ahead and draw this, a line, and we're going to label it T so we know that's a transversal line. It's going to intersect 2 or more coplanar lines. So these 2 lines we just drew are in the same plane. So technically, if that transversal's intersecting on the transversal's in the same plane also. Okay, so just some technicalities there that we got to have. But transversal is going to be a big one for us. So let's kind of star that and go back to it. But I just want to kind of caution you that we're going to add some stuff to that in the next section that becomes very important for you guys, okay? All right, so in this picture here, we got this rectangular prism and it's been all labeled up. So if you don't have the actual notes here, why don't you go ahead and draw that and label it up so you can hit pause and draw a three-dimensional rectangular prism and then label all the points. Okay, so we're looking at this, and what they're asking us is to find another line that's parallel to AB, but it has point D. So, you know, we could see AB, it's the bold line right here, and here is point D. Now I need a line that's parallel to AB, but also contains DC. Now remember, lines aren't going to intersect, so I believe that line right there, DC or CD, is parallel to AB. Okay, so let's see if behind the star if we're correct, and we were. Okay. Now we've talked about perpendicular in question B here. We've talked about perpendicular. That's two lines intersect to make a right angle. Okay. Now I think we all know that a perpendicular line is a right angle, and in a rectangle, all the sides meet at a right angle. Okay. So once again, we're going to look at AB, but we're going to look at a line that contains D that is going to be perpendicular to AB. So having D here, it looks like this line, even though it doesn't really look like that's a right angle. I know that all the angles in a rectangle should be right. So I believe AD would be the correct answer, or DA, however you want to put that. Usually, you know, books are going to go in alphabetical order. Okay. Okay, here we go. This one's going to be tough. So skew to AB containing D. So going in the opposite direction. So if you can kind of see AB, it looks like it should be going in a horizontal direction or flat. Okay, so containing D, not intersecting with AB, but going in the other direction. So if AB is flat, then I need a line that's going to be vertical. And so that should be DH. They're not ever going to intersect, but they're not true parallel lines. Okay, good there. Now we're getting a little tricky here too. Okay, so this question actually has a couple of correct answers. This other line here, DE, it's never going to intersect with AB. Okay, it's not vertical, so it really doesn't have to be in the opposite direction or a different direction. It just can never intersect. Okay, and then if you could see this other diagonal that goes through here, that's never going to intersect with AB. Okay, so all three of those lines, DE and DG and DH, are all skew to AB. Okay, so skew's kind of tough. It's something hard to get wrapped around. That illustration is not super because it is three-dimensional, but on a flat surface, so it's kind of hard to see. So use your room wherever you're in, and kind of use where the walls meet and see how you can kind of illustrate skew. All right. A plane with D and parallel to ABE. Okay, so here we go. We got to look first off ABE. I only need 3 points to label a plane. So ABE is that plane right there. Also contains F. Okay, I have to be parallel to that, and I also need to come back and contain D in that plane that will be parallel. Okay, so to me, it looks like this other side of the rectangle, you know, and I could call it DCG, DHG, use all four, whatever. It looks like that would be a plane that's parallel to ABE. Okay, and we'll take a look, and we're correct. Okay, they use DCH. I could use DHG. You just need 3. Okay. All right, here we go. If you guys go ahead and write in the parallel postulate if you don't have the page of notes, and I'm going to draw a line with it, or I'm sorry, a picture with this definition. And I just want to point out that's a conditional statement. It's an if-then form. Okay? So all rules in math are going to be an if-then form, and we've proven that it's true. Okay, so let me draw this picture. So I have a line, a given line. Here's a line. And then there's a point not on the line. This could be above it or below it, but it's not on the line. It doesn't have to be exactly in the middle, but that's where I'm going to put it. But this point could be left or right of where I got it. It could be below the line, left and right where I got it, whatever. I'm just going to draw it right there. Okay? Now, what this postulate says, and the postulate's like an addendum to a rule. I got this basic rule, but I can have these other little things that kind of hang on to it. It says through that one point, I can only draw one line that's going to be parallel to the one that they gave me. Okay? And so if you think of degrees, if that green line was not flat, if it was 1 degree off of being flat, at some point down the road, it's going to intersect with the black line, okay? But I can draw exactly one line parallel to the given through that point, okay? So the next postulate down here at the bottom kind of says the same thing. It's actually almost exactly the same thing, except we're throwing in a different word. We're throwing in perpendicular, okay? So if you can go ahead and write down that definition if you don't have a note page. And it's also in if-then form. It's exactly the same, but they've switched parallel and perpendicular words in and out. And so we're going to go ahead and draw this one or illustrate this one too. I'm just going to do it the same way. I'm going to give you a line. I'm going to give you a point that's not on the line. It doesn't have to exactly be there. It could be below it. It could be left and right. But what this theorem is saying, through this one point, I can draw exactly one line that's exactly perpendicular to the given line, okay? So once again, you think of degrees, if that thing's not exactly at 90, if it's 89.7, it's not going to be able to be perpendicular to that line, okay? So those are two actually pretty good rules and definitions that show up. We just need to make sure we got that down, okay? All right. So if you guys draw this, this is a transversal. This is the transversal line, kind of what we talked about a little bit ago on definitions. But then if you could number it up for me, please. I'm going to do a little bit of moving around here. Oops, if I can get to a moving around thing. There we go. So it's all together here. You can kind of see some of the stuff we'll talk about. Okay, this is the transversal line. Okay. All right. Once you get that transversal drawn up and the angles numbered, if you guys could draw or write in these headings. Then you can hit pause and come back to it so I can get going here. But one thing, consecutive interior angles are sometimes called same side interior angles. I think we kind of stick with this one a little bit more than consecutive. Okay. All right. So what we're going to do here is I'm going to write out a little definition for each one, and I want and have you guys kind of write that down, and then we're going to identify angles that kind of meet those definitions for each of the four headings. Okay. So for corresponding angles, they're on the same side of the transversal. In corresponding positions. Okay, so I'm going to do these one at a time so we don't get too messed up here. Okay, same side of the transversal. So the transversal line is kind of a up and down or vertical line. It's not true vertical, but it's up and down. So really, I've got a left side of it, which contains angles 1, 3, 5, and 7, and I got a right side of the transversal, and that's including angles 2, 4, 6, and 8. Okay, so I'm looking for angles that are on the same side but in corresponding, which means about the same place as a particular angle. So let's look at angle number 1 to start off with. Okay, so angle number 1 is on the left-hand side of the transversal, so I'm looking for another angle that's on the left-hand side, but in the same place or position. And so angle 1 is sitting on top of this line. So I need another angle that's sitting on top of a line on the same side. So the only other angle that's doing that is angle 5. It's on the left-hand side of the transversal. It's sitting on top of a line. So angles 1 and angles 5 are corresponding angles. Okay. All right. Let's just look at 3 then, since we're on the left-hand side. Angle 3 is on the left-hand side, but it's sitting on the bottom of this particular line at the top. So I need another angle that's sitting at the bottom of a line on the left-hand side. Well, the only other angle that's doing that is 7. So angle 3 and angle 7 are corresponding angles. Same side of the transversal in the same position. Okay. All right. So let's go to the right-hand side of the transversal now. Okay, and let's start with angle 2. Angle 2 is on the right-hand side of the transversal line. It's sitting on top of this line. So I'm looking for another angle that would sit on top of a line. Well, and on the right-hand side. The only one that's doing that is 6. So angles 2 and angle 6 are corresponding angles. Okay. So I'm going to continue on. Right-hand side, angle 4 is sitting on the bottom. I'm looking for another angle that's sitting on the bottom. That's got to be angle 8. Okay. So angle 4 and angle 8 are corresponding angles. Okay. All right. That particular group of angles, corresponding angles, has the most possibilities. Okay. All right, let's go sideways and go over to alternate exterior angles. So here we go. We're going to write the definition, then we'll find these angles. So alternate means different sides of a transversal. And angles are on the outside of the transversal. Okay, I'll let you guys add that. Of the transversal. I ran out of room. Okay, I'm going to get rid of this stuff I did for corresponding here. Okay. Okay, alternate. Different sides of a transversal. So remember, we talked about sides of a transversal. My transversal line is kind of up and down, so I got a left side and I got a right side. So alternate angles are going to be on the left and on the right. Exterior means on the outside. So let me kind of explain that. If you look at this transversal, between the lines here, I've got those angles, but they're between the lines. We would call that inside. Or if you'll notice, we have this word interior over here, so it's going to be the interior of the transversal. Okay, so hopefully that makes some kind of sense. So alternate or exterior angles are going to be outside those two lines. Okay, so let's take a look at angle number 1. I hope you agree with me that it's on the outside, or it's not between the two lines, it's outside the lines. Angle number 1 is on the left side. I need an angle that's on the outside and on the other side of the transversal. Well, this angle 8 is on the outside and it's on the right-hand side of the transversal. Okay, so those two angles, angles 1 and angles 8, are alternate, different sides, exterior on the outside angles. Okay, so once again, I'm looking for outside angles. I started with 1. I hope you guys understand angle 2 should be an exterior angle. And I look, and it's on the right hand side, so I got to go look on the left hand side, an angle that's on the outside on the left. And I think that brings me to angle 7. So angles 2 and 7 are alternate exterior angles. Okay. All right. Let's come on down over here to alternate interior angles, since we're talking about alternates. Okay. So alternate means the same thing. So different sides of a transversal and on the inside of the transversal. Okay, so go over this really quickly again. Alternate means, in this case, left and right. I've got a left-hand side of the transversal, I got a right-hand side of the transversal. But I also talked about earlier interior, or between the two lines that are intersected, okay? So I'm looking on the inside, and let's just start with angle 3. So angle 3 is on the interior of the transversal. It's on the left-hand side. I want alternate, so that means I got to go to the right and another angle that's opposite it, okay, and on the interior, okay. So angle 6. So angle 3, come down here, sorry, I got to squish it. Angle 3 and angle 6 are alternate interior angles, okay. And you know, you could make a case, well, isn't 4 an alternate interior angle? And it technically is, but what happens here is that we'll talk about later, but 3 and 4 actually is called something else. They're actually making a line, and therefore they're a linear pair and not alternate interior angles. So you might have been asking that question. So you kind of notice I'm going diagonally across for that one. Okay, so angle 3 and angle 6. So then I need another. I think there's another pair. I'm going to look at angle 4. Is there 4 is the interior angles between the lines. It's on the right-hand side this time. So something opposite that or alternate of that is going to be angle 5. Okay, it's also on the inside. So angle 4 and angle 5 are alternate interior angles. Okay. So hopefully you got that. Now remember, guys, too, there's a lot of stuff here. There's a lot of stuff you got to know. You got to study it. And, you know, if you're not really sure, you need to be talking to me and getting some help. Okay. Don't hesitate to do that. Ask as soon as you are getting kind of lost. All right. Okay. Same side interior angles or consecutive interior angles. This one, you know, you just got to kind of take the words. Let's stick with same side interior angles because I think that's pretty much what you're going to hear. But know that these two terms are the same thing. So same side sounds like what it says. Same side. It's the same side of the transversal and it's on the interior of the transversal. Okay, so between the lines. All right. So one, I know that I'm looking on the inside. Both of these terms, consecutive interior angles and same side interior angles, have the word interior. So between the lines, all right? Okay. I'm going to start with angle 3. Now we got to be, this is what we got to make sure we get all these different terms down. So you got to study same side. So same side of the transversal on the inside, and that looks like it's got to be probably angle 5. Okay. So angle 3 and angle 5 are same side interior angles. All right, I'll come back up here to angle 4. It's on the right hand side. Same side means the same side, or in this case the right. And the only other angle that's on the same side and on the interior is angle 6. Okay, so angle 4 and angle 6 are same side interior angles or consecutive interior angles. Okay, now so let's just make sure we're clear here. Angle 4 and angle 8 are on the same side of the transversal, but 4 is inside of it and 8 is on the outside. And if you go all the way back to the very first thing you did was corresponding, 4 and 8 actually were corresponding angles because they're in the same place on the same side of the transversal. Okay, so a lot of kids kind of get those mixed up because the one, they don't study, 2, they don't really pay attention. You got to make sure you got this stuff down. Okay, all right, so that'll kind of take us to the end of that. If you got any questions, make sure you ask and we'll get moving from there. All right.